Alright, this is Mr. Gillum, and today we're going to talk about exponential growth functions for the first time. So we're going to keep it simple with t-charts. But here's what an exponential growth function is, okay? It's in the form y equals ab to the x. Now, it's very, very important that you understand there's always two numbers there, okay? An a value and a b value. B is like the base value. It has an exponent on it, okay? There's a couple things your book wants me to go through. Okay, they're basically just common sense things, kind of. Okay, a can't equal 0 because if a was 0, then y would equal 0, and it'd just be a line. Okay, so obviously a can't be 0, and b has to be a positive number greater than 1. All right, positive number greater than 1. So the b value is always positive. Okay, if a is bigger than 0 and b is bigger than 1, it's exponential growth. Okay, and we're gonna talk about the difference between growth and decay more next lesson. So here we go. The growth factor. Okay, it's the b value. Okay, it's represented by the b value. Very, very important that you understand when I refer to growth factor, I'm talking about the b value, the one with the exponent on it. Okay, and it's going to determine how fast it rises. Okay, the word exponential means quickly. Okay, it quickly rises, exponentially rises. And it goes really, really fast, rises very quickly. So it's the b value, the one with the exponent, and then the asymptote is, I think this should be new for everybody in here. An asymptote is a line that a graph approaches but never crosses. Okay, so for instance, let me just give you an example here of what we're talking about here today. An exponential growth function, here's what's going to happen. Okay, it's going to get really high really fast, and it's going to keep going to the right forever, but it's going to go up higher, 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 very, very fast. Okay, and then it's going to come really close to something like, say, the x-axis, and it's never going to touch, but it's going to come really close, and it's just going to go forever, really, 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 really close to the axis, but it'll never cross, but it'll keep going on forever. Okay, that's because there's an asymptote at 0. Okay, it's like a boundary line. It's never going to cross that. Okay, so that's the first time we're going to talk about asymptotes today. There we go. We are going to graph exponential functions beginner style today. Okay, so we're just going to just make a t-chart from -2 to 2, plot the points, connect the dots with a smooth curve. Okay, there will be an asymptote. All right, there will be an asymptote. So for today, I'm not going to tell you how to figure out what the asymptote is, but you should be able to tell by what your graph approach is. Okay, I'll give you a hint. It's always going to be 0 today, so it's going to be pretty straightforward. All right, so what it's going to say is graph the exponential growth function, state the domain and range. And we've talked about domain and range recently with square roots and cubed roots. Okay, and it's the same thing for as far as domain and range. It's always the same thing. It's always the x values and the y values. Okay. Now, I wish I would have put this example a couple more in, but here's what you understand. Okay, exponential growth for today is y equals a b to the x. Please make sure you understand there are two numbers there. Okay, there's an a value and a b value. Even though there's not two numbers here, okay, see how this has an exponent on it? That's the b value. The b value, the growth factor, always has an exponent on it. The number in front of this is really 1 times 2 to the x. Okay, so there is an a value and a b value. Okay, always. Even if there's just one number, there's always an a and a b. Okay, please understand that. That's very, very important for tomorrow. There's an a value and a b value. So what we're going to say is, okay, even though there's not a 1 there in the problem, we don't really need it today, really, but there is an a and a b. We're just going to do a t-chart from -2 to 2. All right, and I'm just going to plug them in here. Y equals 2 to the -2, to the -1, to the 0, to the first, 2 squared. Okay, keep in mind what a negative exponent does. We did this a lot last chapter. It moves everything to the bottom, 1 over 2 squared, which is 1/4. So I'm going to put 1/4 there. 2 to the -1 is 1 over 2, 1/2. 2 to the 0, that's 1. 2 to the first, 2, 2 squared, 4. Okay, now I have my t-chart. I'm going to go over here to my graph. I'm going to plot all the points. I'm going to make a nice smooth line. -2, 1/4 is a little bit above -2. -1, 1/2. 0, 1, 1, 1, no, sorry, 1, 2, and 2, 4. All right, and so what's going to happen is we're going to connect these with a smooth curve. All right, something like that. But when you do that, do not cross the x-axis, okay? As you can see, the more points I plug in the negative side, the closer it's going to get to 0, but it will never actually cross 0, okay? It'll be a smaller fraction and a smaller fraction and a smaller fraction and smaller and smaller and smaller. No matter what number, what negative number I plug in, it will never be 0. Okay, so it's going to come really close to 0, but it's never going to touch. So I'm just going to go ahead and put a little dotted line here. I'm going to say that's the equation of that. Asymptote is y equals 0, okay? Y equals 0. So draw that little asymptote on your paper. Okay, you can make it continuous because it goes on forever as well. All right, it's just a boundary line that the graph's never going to cross. Okay, so basically today all we're doing is t-charts. Okay, they're always going to approach an asymptote. Today at 0, tomorrow in different places, but for today at 0, and we need to talk about the domain and range. The domain and range is the same as with cube roots, square roots, all that stuff. Okay, the domain and the range. The domain is from the smallest x value to the biggest x value, anything in between, anything included in the graph. The smallest value to the left, as you can see, it goes on forever to the left, is negative infinity. Okay, we don't know what it is. We can go forever that way. To the right, even though it's going to be a really high number, the farther we go to the right, there's always going to be another x value. So actually the domain is all real numbers. Okay, it goes forever to the left, forever to the right. Okay, it goes very high. It gets very large to the right, but it does go on forever. The range is the lowest point to the highest point. Now here's where things change a little bit. Okay, we're used to using brackets for numbers, okay, but that doesn't always happen when you have asymptotes, okay. Like I was just saying, the lowest point to the highest point. The lowest point on this graph it's ever going to come to is something really, really, really close to 0. It'll never touch 0, but the lowest point is like really close to it. And the highest point, it goes on forever, it's positive infinity. So if it's coming really, really close to 0 but never touching, I don't want to include 0 because it never actually touches 0. I'm going to go ahead and use a parenthesis. Okay, 0 to positive infinity, the lowest point to the highest point. Okay, so there's the domain and range of this thing, and that's an exponential growth function. All right, so let's look at another one here. On this one, it's pretty obvious what the a and the b value are. Okay, the b value represents the growth factor. A is 1/2. And b is 4. So the bigger the growth factor, the bigger the number right here under the exponent, the faster it's going to increase. So let's just take a look here. We're going to do a t-chart. From -2 to 2. And we're just going to plug these values in. 1/2 times 4 to the -2. Okay, and remember when you multiply fractions, you can always multiply straight across and cross cancel if you can. That'll make it easier for you. Okay, 4 to the -2 is really 1/4 squared. So I'm going to write 1/2 times 1/16. That makes 1/32. Okay, this guy right here, 1/2 times 1/4. This guy is really 1/4. If you multiply straight across, 1/8. 1/2 times 4 to the 0, that's 1/2 times 1, which is 1/2. 1/2 times 4, if you cross cancel, really that's 4/1, you get 2. And finally, 1/2 times 16, you get 8. Okay, so I'm just going to put those numbers in my t-chart here. 1/32, 1/8, 1/2, 2, and 8. I'm just going to plot them on my graph over here. X and Y. -2, 1/32. Okay, just barely above 0. -1, 1/8, just barely above 0, but a little bit farther away than the last point. 0, 1/2, 1, 2, and 2, 8. Right there, that guy. Okay, so now I got my points on my graph. I just need to make a nice smooth curve, and as you can see, it got really big really fast. That's why it's exponential growth. I bet if we pick 3, it'd be even really big number. Okay, it's exponentially increasing in size. So I'm going to go ahead and connect these dots here, smooth as I can, and make sure you don't cross that x-axis, okay? It's very important because there's actually an asymptote there. It's never going to cross, and as you can see, no matter what point I pick, the bigger the negative number, I'm still not going to end up with 0. And that equation of that asymptote would be y equals 0, horizontal line, y equals 0. So we got this exponential growth function. Looks pretty good. Now all we have to do is talk about the domain and range. The domain, anything x can be, it goes forever to the left and forever to the right. So I'm going to say it goes from negative infinity to positive infinity. The range, okay, the lowest point on the range is 0. The highest point is positive infinity. Okay, it's never going to go below 0. So I want to use 0 as a boundary, but I don't want to include it, so I'm going to put a parenthesis, and it goes up forever to positive infinity. All right, so there's 2 examples. Let's do a couple more here. Start going through them a little quicker. Okay, I want to stress this again. Okay, the exponential growth functions are in the form y equals ab to the x. Okay, there is an a value and a b value. The growth factor will never be negative, so really this a value would be negative 1. Okay, I want to point that out today so that for tomorrow, everybody understands there's always 2 numbers there. Okay, even if there's not 2 numbers written, there's always an a value in front of it. Okay, the growth factor this time would be 5/2. Start with a t-chart from negative 2 to 2. And so y equals negative 5/2 to the negative 2. Y equals negative 5/2 to negative 1. And, oops, that negative should be on those last 2. The negative should be on the outside of the parentheses. That does make a difference, actually. Okay, and then I'm going to show you, I don't know how much we actually talked about this, but this negative exponent is literally just going to flip the fraction around. We can use a power rule and do all that stuff, or you can just take the reciprocal of the fraction here. Negative 2/5 squared. When you square fraction, you square the top number and the bottom number. So I'm going to say this is really negative 4/25. And there's my first value. Same way with this one. If you have a fraction to a negative exponent, what you can do to get rid of that negative is just flip it over. Okay, so I'm just going to say this is negative 2/5, which is just the same. It's all the first, but that's really just negative 2/5. Anything to the 0 power is 1. However, this negative sign still needs to be accounted for. So it's negative 1. This guy, okay, 5/2 to the first doesn't change. Negative 5/2. And finally, this last one here, if you're squaring a fraction, you square the top number and the bottom number, so negative 25/4. Okay, so there's all my t-chart values. I'm just going to plug them in here. Negative 4/25, negative 2/5, negative 1, negative 5/2, and negative 25/4. All right, and what I want you to notice is that this is the first example where we had a negative number for the a value. Okay, it's actually really important because what's going to happen is our graph's going to flip upside down. I'll show you why. Negative 2, negative 4/25. So we're going to negative 2, negative 4/25, just a little below. Negative 1, negative 2/5. A little below, but a little farther than the last one. 0, negative 1. 1, negative 5/2. And 2, negative 25/4. So negative 6 1/4. 1, 2, 3, 4, 5. Right there. So once again, I'm going to make a nice smooth curve through all my points. I'm going to make sure I do not cross the x-axis because no matter what point I plug in there, it will never go above 0. Okay, it will never do that. So make sure on your graphs, on your homework, that you don't cross that line because that's showing that you understand that there is an asymptote there. Okay, and the asymptote, the equation of that line would be y equals 0. Okay, as far as domain and range are concerned, okay, these are all kind of the same idea. It goes to the left forever, goes to the right forever, therefore it's all real numbers from negative infinity to positive infinity. The range is the lowest number to the highest number. Now the lowest number is, we don't know what it is, it goes down forever. So the lowest number, negative infinity, we're not sure what it is. The highest number, it'll never cross 0, so we're going to use 0 as our boundary. It never goes above 0. So we're going to say 0 right there, and we don't want to include 0 because it'll never actually touch 0, so I'm going to put another parenthesis there. All right. Looking at this one here. Okay, once again, I want you to understand that there's an a value and a b value. Y equals a, b to the x. So we're going to say the a value this time would be 1. Okay, I'm pointing that out for tomorrow so for the sake of you understanding that. So we're just going to go ahead and t-chart here. Same thing. And we'll go through it a little quicker this time. This one's a little bit more simple. 4 to the negative 2, 4 to the negative 1, 4 to the 0, 4 to the first, 4 to the second. Just remember that negative exponent flips it over. We have 1/16, 1/4, 1, 4, and 16. And because our a value is positive, once again, I think it's going to go up in the up direction. We'll see what happens here as we graph it. Negative 2, 1/16, we're barely above 0. Negative 1, 1/4, a little bit above 0. 0, 1, 1, 4, 2, 16. So 2 got big really fast. Up here somewhere. Okay, so that's why it's exponential growth, because it increases very, very quickly at a high rate. I'm going to go ahead and draw my curve in there, and I'm going to make sure never to cross the x-axis today, because there's actually an asymptote there, and I'm going to label my asymptote. Okay, y equals 0. That's the equation of that line. Y equals 0. It's never going to cross that. Last but not least, domain and range. The domain goes to the left forever, goes to the right forever. That means it's all real numbers, from negative infinity to positive infinity. And the range, the lowest number to the highest number. Now, once again, it's never going to touch 0, but it is the lowest value. So I want to use 0 as my boundary. I don't want to include it with a bracket. Okay, brackets are included. I want to use a parenthesis because it's just a boundary. And to positive infinity, it goes in the positive direction forever on the y-axis. Okay, I think we got one more to do. And we do. All right. Once again, if you hear me refer to growth factor tomorrow or today or whenever, okay, I'm talking about the value that has the exponent on it. Okay, so our growth factor this time would be 3, which means it's going to increase a little faster. The bigger the growth factor, the faster it increases. Okay, and this 1/2 would be the a value. So I want to do another example with fractions in it just so we can have one. X and y, negative 2 to 2. So y equals 1/2 times 3 to the negative 2. And all this stuff. Okay, so let's just do our work here. This guy is really 1 over 3 squared. So I'm going to go ahead and write 1/9. So I have 1/2 times 1/9. That's 1/18. This guy is really 1/3. So I'm going to write down 1/2 times 1/3. Multiply straight across, 1/6. This guy is really just 1, and 1/2 times 1 is 1/2. 1/2 times 3 over 1 would be 3/2. And finally, 1/2 times 9 over 1 would be 9/2. Okay, so I'm just going to put those in my t-chart here. 1/18, 1/6, 1/2, 3/2, and 9/2. Okay, and go into my graph here. I'm going to say negative 2, 1/18, barely above 0. Negative 1, 1/6, 0, 1/2, 1 3/2. Okay, now it should get 2 9/4, 1 2 3 4.5 right there. Okay, there it is. Nice little growth function there, exponential growth function. And it's never going to go through the x-axis, so be careful on your paper not to draw it through the x-axis. I'm going to draw my little asymptote here, and the equation in that line equals y equals 0. Okay, and just to remind you where I'm getting this asymptote equation from, we talked about lines at x equals. Okay, if we have an x equals like 5, then you go to 5, and it's a vertical line. If you have y equals -2, that's a horizontal line at -2, and we did that a long time ago in a chapter a long time ago. So that's why I'm writing y equals 0 there, because a horizontal line at 0 would be the equation, y equals 0. Okay? Domain and range, real quick, let's just do those. Domain, once again, goes to the left forever, goes to the right forever, so we're going to say it's all real numbers, from -infinity to +infinity. The range, the lowest number to the highest number this time, okay? The lowest, it's never going to cross 0, so we're going to say 0 is the boundary. It's never going to touch 0 either, so that's why we're putting a parenthesis. And the highest number is +infinity. Okay, we don't know. It goes on forever towards the top with a parenthesis.